NOR flash memory is the backbone for a lot of development. Processors use it all the time. You have a 3D NOR, which is definitely going to increase capacity. Could you tell us a little bit more about it?
Well, I think in the NOR flash area, because the quality reliability concern, the best we can do is 50 nanometer technology. So the largest density you can ever achieve is 512 meg. Of course, we can stack 2 dies, 4 dies to make a bigger density, but cost will be much higher, and also quality will be downgraded. So we believe there's a big need for the higher density because the system development require it. So we believe having a 4 gigabit NOR flash become important. So the only way to make it happen is using 3D technology. So what happened is we're trying to stack many transistors into 30 level, so we can get into small die with the 4 gigabit flash density. So that's the intention to make these devices.
Very good. Now, NAND has been stacking for quite a bit, but they're a different application space. Can you talk about the NOR space and why this is going to be advantageous?
Yes. Well, I think for high density, of course, cost become concern. So some people start to adapt NAND, 3D NAND solutions. But the problem is NAND devices has a very lousy quality because the P cycle is very, very low. And also you need a lot of logic chip to improve the overall quality. So the overall cost may not be increased a lot, but the area will be increased a lot. So for a lot of application, you need small scale environment, and then you are in trouble. So we believe that the NAND is not going to be the solution, and that's why we developed 3D NOR. So hopefully, with the NOR solution, we can do much better job. At the same time, so we can reduce the cost a lot.
Okay. Could you talk a little bit about the difference between NAND and NOR? Why is NOR advantageous?
Well, basically, the NAND devices is using different structure. That's what they call the NAND, right? So because the structure of the devices, you can make the chip much smaller. At the same time, the application is different. In the beginning, the application of the NAND is for storage. Even you lose 1 bit data, you don't care. But NOR is using for the system requirement, so you cannot lose any bit. And they are using the NOR structure, so that by definition that you're going to stress the device much more times. So that's why the NOR can be used for cold storage and then for data storage. So I think that is the fundamental difference between these two. But if you try using NAND rather than for the data storage, and now they're trying to do the cold storage, there will be a lot of challenge you need to change that.
Now, NAND is essentially block-oriented. What about NOR?
Well, basically you can access into individual bit. So that's where you can control the data much more accurate. So because each individual cell is important for the data you're talking about. Because of that, that's why we developed these 3D NOR devices. But in our current 3D NOR device, we have a lot of different features on that. Number one feature we are doing is, we are able to maintain the 2D quality, but at the same time, we are able to improve the speed, because 2D NOR generally has a problem is the speed is very slow, because that's what you can do is on the 8-bit, 1-bit, 4-bit, 8-bit, 16-bit devices. But your access is very, very slow. So our 3D devices, we are able to create DDR4 interface. So that means we can bring our NOR flash in the same speed of the DRAM. So
that's
that
impressive.
will, yeah, that will be making the system design much simpler. Because used to be you have to download everything into DRAM and then you need to move around. So now you can, because the facts you can download to different area depending on applications. With that in mind, and actually we figure out that you can reduce the DRAM usage by 30%. That will be reduce a lot of system costs on that. So.
It would probably also be more power efficient, wouldn't it?
Oh yes, yes. Right now I think we believe that with the 3D NOR, you can make the system design much simpler. I think when you have a simple system design, means it's quality. So I think the overall cost and overall return from field would be much lower compared to NAND.
Okay. So where do we stand now? What's the latest that you have, and where do you see this headed?
Well, first is we already have a working devices. Even though I think we still have a room for improvement, because this is a new technology, new design, we're still trying to understand a lot of behavior. We are trying to improve that. So we are really working. We have a working device. We demonstrate in the last year's electronics show in Munich. What we're trying to do is we are trying to offer the working commercial sample by end of this year.
That sounds good. Well, thanks for filling us in on 3D NOR technology.